This worked example is kind of the reverse of example 15, and what we're doing, we're using those same formulas for a vector which has a1, a2 and a3 as the coefficients of I, j, k, and where a, alpha, beta and gamma are the angles that are made with the x, y and z axes respectively. Now we have a position vector that's given to us in 2 dimensions. It has a magnitude of 5 and its direction measured anti-clockwise from the x-axis is 150 degrees. So we've got a little bit of information there. So I'm just going to draw just a rough 150 degrees is kind of there. And then we know that we've got a vector. It's a position vector to some point P. And we know that the magnitude of that vector, O to P, okay, so the origin to P, we know the magnitude is 5. Okay, now let's let that vector O to P, we'll give it a form. Let's call it, we can call it actually A1 and A2, so it matches up. A1, and it's IJ, so we only need 2 dimensions, A1I plus A2J. Now we can use the formulas here, okay, which we know. So first one, we can find cos alpha. We're going to use this formula, is A1 over the magnitude of OP. Now if we think about what alpha is the angle that's made with the x-axis. And we know that the angle that's made with the x-axis is 150 degrees because that's that entire angle there. So we know alpha equals 150 degrees. Okay, so we have cosine of 150 degrees equals A1 on the magnitude of OP, which we know, which is 5. So that means that A1 equals 5 times cosine of 150 degrees. So we know 150 degrees, I'm just putting some working here, you don't really need this working, is 5 times 30 degrees. So that's going to be 5 times pi on 6. And we know that from our triangle, pi on 6 cosine is root 3 on 2, and we're over on this side. So it's going to be cosine of 150 degrees will be negative root 3 on 2. And it'll be 5 times that for A1. So that gives us what A1 is. And that's the coefficient of I. So therefore A1 equals negative 5 root 3 on 2. The next part, J, we know that we need for J, we can use, for J, we're going to use the second formula. So cos of beta equals A2 on the magnitude of O to P. And we know that here, if we have a look at the picture, I'll just do this in different colour, you can see the angle beta that's made with the y-axis is this angle here. And we know that this is 90 degrees, so this angle in here, I'll do in blue, that would be 90 taken away from 150, so that would be 60 degrees in there as the angle from the y-axis. So that means that beta, we know that beta equals 60 degrees, so that's the angle from the y-axis. And 60 degrees is pi on 3. So again, from the formula, from your, from your magic triangle, you know that pi on 3 cosine half, and so we can put that in here. So we're going to write down the formula there. We've got cosine beta equals, we know A2 is what we're trying to find. The modulus is 5, and we know that cosine of beta is a half. So we've really just got this expression here. Okay, and then trying to solve that, we're going to end up with A2 equals, bring the 5 over, so we've got 5 over 2, or 2.5 if you want it as a decimal. So what that's told us is what A2 is, and also what A1 is. And remember that those are the coefficients in this vector ij. So we can now express that final answer as a vector. So just going back, I'll just put the answer up here. So therefore, our vector O to P is given by A1, which is negative 5 root 3 over 2i, plus A2, which is 5 over 2j. So that's the format for our vector O to P.